What I want to do with this video is illustrate how using your main engine to both propel the boat and generate electricity can improve its efficiency substantially. Now, if we look at this page on the screen, the top line is the amount of fuel being used to propel the boat in litres per hour. Second line is the amount of fuel being used to generate electricity in litres per hour. Third is the total amount of fuel that the engine is consuming. And the fourth line, marked economy there, is how many grams of fuel we're using to produce a kilowatt hour of useful work. So the less that number, the better. Except at the moment it says 0 because we're not actually doing anything useful. So the engine is ticking over, not propelling the boat, not generating power, and it's burning 0.6, 0.7 of a litre per hour. If I now turn the generator on by pressing the go button, it takes a little while to think about this. We don't like to surprise the engine by putting big electrical loads on it too suddenly. But once the control system is happy that it's safe to do so, it will slowly begin to wind up the electrical output. Okay, so you can see it's now building very gradually, not putting any shock loads on the engine. And now we can see that the fuel that the engine is burning is beginning to do some useful work. So the second line there, generator fuel, is showing us that we're burning 1.2 litres an hour, and that's going to produce 2.3, 2.4, 2.5, 2.6 kilowatts of electrical energy. So total fuel consumed 1.3, 1.4 litres an hour, and the energy being produced is 2.8 kilowatts. That gives us an economy, a specific fuel consumption of roughly 400 grams per kilowatt hour. I've now put the boat into drive, so the propeller is turning. Two things you'll notice. First is that propulsion fuel is now 1.1 litres per hour. In other words, the fuel that we're consuming is going to turn the propeller. But the economy is still pretty poor, 800, 900 grams per kilowatt hour. That's this number here. Now, as the generator starts to kick in, watch what happens to that propulsion fuel. It was at 1.1, 1.2 litres per hour, and it's dropped down to 0.6. So we're now using roughly half the fuel that we were using before. Propeller's turning at the same speed, the boat is going at the same speed, but because the efficiency has improved massively as a result of the electrical load, the litres per hour for propulsion is half what it was without the generator. And the generator fuel is now at 1.4 litres per hour, giving us an overall fuel efficiency of roughly 400 grams per kilowatt hour. So by adding the generator into the mix, you actually significantly improve the propulsion fuel efficiency, and in this case at tick over we're improving it by more than 50%.